It is time now to revisit our most favoritist unit in chemistry, moles. And much like in honors chemistry, this will haunt you for the rest of the semester. The good news is that it's not any different than it was in honors chemistry. The bad news is that it is going to be a part of everything we ever do ever. So we're going to make sure that we're good at this before we move on to the next thing. And as a reminder, we still have, all the stuff is still the same, except we are going to use a slightly more specific number for Avogadro's number. So 1 mole is 6.022 times 10 to the 23rd atoms or particles or molecules or formula units or whatever. Okay, Avogadro's number can be used to count anything, but the reason why we use it in chemistry is it is most useful when it's counting small particles. And by small, I mean like electrons. Okay, not like, a cat, which is relatively small. The other useful concept is if you have a mole of a substance, then the mass on the periodic table correlates with that in grams. So for example, if you have 6.02 times 10 to the 23rd atoms of carbon, then it's going to be 12 grams. If you have a mole of oxygen, it's going to weigh 16 grams, etc. And that also works with molecules. You just have to add all of the atoms together. So we're going to keep hitting this turn names into formulas thing. If you have nitric acid, okay, you are going to need to know what the formula is because the question asks for mass. And in order to use the mass, we have to know how many atoms of each of the elements there are. So if it's an acid, it starts with H. If there's no hydro in front of it, that means it's a polyatomic ion. Okay, IC means it used to be ATE, so this has to be HNO3. We're going to start with 15.7 moles. Okay, and this is just a conversion factor. 1 mole is the mass on the periodic table. So mole is going to go down here in order to cancel out, and then we'll put the mass of HNO3 up on top. And the way we figure that out is by adding all of the atoms together. And the molar mass of nitric acid, if we're following the rules of adding decimals together, we need to keep 2 decimals, is going to be 63.02 grams. So you're really just taking 15.7 multiplying by 63.02. The answer that we get for this does also have to follow the significant figures rule. We had 3 sig figs here. We just calculated that to 4. So the answer that you get, you need to round to 3 sig figs. Multiply by 15.7. And it is 989 grams. Okay, now, are you a terrible, horrible, no good person if you have 989 and you forget and put 0.4? No. Okay, it's at the most going to be worth a half a point. So if you are concerned about getting as many points as possible, you do need to keep track of sig figs, but I will not destroy your soul if you accidentally put a decimal on there. Okay, so this question is basically the same thing, except I do want to point out there are questions in the textbook where they have this going on. Okay, this is a millimole, which means that you do have to use a metric system conversion in order to get the answer to this question. So we're starting with 72.1 millimoles, but we don't have a direct conversion for that, so we need to switch it to regular moles. Okay, milli is down below on the periodic table, regular mole is up above, so that means we're going to be dividing by 3 steps. Okay, this is a millimole. This is a regular mole. So the first thing that's going to happen is we're going to move the decimal place and realize that we're talking about only 0.0721 moles of SO2. The next step is to actually do the mole conversion. Sulfur dioxide weighs 64.07 grams per mole. And then you multiply to solve. The answer is 4.62 in order to keep with the 3 sig figs that we have here, grams. Moving right along, okay, hopefully you remember what water is, H2O. A lot of times in the book it will just say water because that is like the most basic thing that you have to know the symbol of. We're going to start with 3.011 times 10 to the 23rd. So this question has us using Avogadro's number. And instead of using mole, we're just going to skip right through it and use 6.02 times 10 to the 23rd. Okay, we know that a mole has this many particles in it. So if we're going to try to get rid of molecules, then we have to use this number in order for molecules to cancel out. And if you add water up, The mass is about 18.02. Oop, that doesn't really look like an 8. Okay. So in this question, since we don't have 1 on either side of the fraction, you do have to multiply and divide. And the answer is 9.01 grams of H2O. Same question, but opposite direction, and instead of water, we have carbon dioxide. So we have a mass of 44.01 grams. Okay, so we have 10.8 grams. There's nothing wrong with that unit, so we don't have to do any metric switches. We know that 1 mole would weigh this many. Okay, we need to divide by it so that grams cancels out. The question asks for molecules, so you can do 1 mole here and solve that and then use Avogadro's number to do a second step. Or you can remember that you don't really need to do 2 steps. 44.01 grams is equal to Avogadro's number. So we're just going to go ahead and use that and save ourselves a step. So multiply and divide. And the answer is 1.48 times 10 to the 23rd. I did limit it to 3 sig figs because of the 10.8. For a more complicated question, this one is asking you to find an answer to something that is sort of beyond the scope of a regular mole problem. So we have the millimole situation, but we also have a very specific part of water. Okay, in order to get from the first part of the information, which is the 5 millimoles, to what they actually want you to answer, we do need to figure out how many molecules of water are there first. So I'm going to go ahead and set it up like we do every problem. Start with the number that's in the question, millimoles. Okay, millimole is really no good for us. Okay, so we need to switch it to regular mole. In 1 mole, there's 10 to the 3rd millimoles. So we really have 0.00500 moles of H2O. The next step, we're working our way towards this unit. Okay, atoms is a particle word, which means the mass of them does not matter. It's the number of them we're looking for. So we're going to take the 0.00500 moles, and you would multiply by Avogadro's number, times 10 to the 23rd molecules in 1 mole. And the answer to that is 3.0, oh, that 3 really didn't work out. 3.01, that's 3 sig figs, times 10 to the 21st. Okay, so here's the problem. This is molecules of water. The question wants to know how many atoms of hydrogen are in that amount of water. There are 2 hydrogen atoms for every molecule of water, so the last step would be to multiply by 2. And the answer, the final answer would be 6.02 times 10 to the 21st, running out of room. And our new unit is atoms of, oh no, whoops, okay, I totally meant to do that. Atoms of hydrogen. So you won't be expected to do that for every single question, but I wanted to throw it in there in case you have to, do something like that in a lab where you're breaking a molecule down into more pieces than just, how many particles are there in a mole.